The golden ratio, which is A plus B, is to A as A is to B. This means that the golden ratio is found by dividing a line into two parts, as you can see in this picture, so that the longer part is divided by the smaller part is also equal to the whole length divided by the longer part. It is often symbolized using phi, after the 21st letter of the Greek alphabet. These numbers of the golden ratio go to infinity, as does pi. However, it is usually rounded to 1.618. Historically, the number can be seen in an architecture of many ancient creations, like this picture of the Great Pyramid of Giza. In this example, the length of each side of the base is 756 feet, with the height of 481 feet. The ratio of the base to the height is roughly 1.5717, which is close to the golden ratio, or 1.618. The Fibonacci sequence is a set of numbers that starts with a 1 or a 0, followed by a 1, and continues based on the rule that each number is equal to the sum of the preceding two numbers. Follow this image, starting with 0, 1, 1. The sum of 1 and 1 is 2. The sum of 2 and 1 is 3. The sum of 2 and 3 is 5. The sum of 3 and 5 is 8, and so on.
Symmetry is when a shape can be divided into identical parts. Whether you split it down the middle or into multiple pieces, each would be perfectly even. For example, look at these snowflakes. How many ways can you divide them with them remaining symmetrical? Or, for another example, who likes pizza? Well, imagine you're at a party and there's one large pizza for 8 people. Everyone would want the same size piece, right? So, you would divide the pizza in half. Then, cut those halves into halves. You're left with quarters. Then cut those quarters into halves to create 8 symmetrical pieces of pizza. Yum! Patterns are created by the repetition of one or more shapes isometrically. These repetitions are known as rigid motions because the shape remains the same, only its position changes. The 3 rigid motions are translation, rotation, and reflection. Translation is where the shape is moved in any direction on the horizontal and vertical plane. Rotation is when the shape revolves around one stationary point. And reflection is where the shape is mirror imaged across one or both of the axes. Wallpapers are a great example of symmetrical patterns. The shapes repeat over and over without ever changing. Take a look at these examples. Even though only a portion is shown, you can easily predict how the pattern would continue. Fractal patterns are similar to symmetrical patterns because you can predict how the pattern will continue, but the shapes aren't the same size as the pattern goes on. A fractal pattern cannot be isometric for this reason.
A fractal is a pattern that exhibits similarity at even finer scales. This means that if you zoom in on a fractal, you will still see the same pattern. Here is an example of a fractal. You can tell it is a fractal because it is using the same spiral-like pattern over and over again to create a bigger spiral pattern that is similar. The word fractal was invented by Benoit Mandelbrot in 1975. It comes from the Latin word fractus, in which we also get fragment, fracture, and fraction. Mandelbrot was born in Poland in 1924. He eventually moved to the United States to work for IBM. He found that many phenomena feature both repeating patterns and power curves, and that the patterns are repeated in a change of scale. Fractals have practical applications. Fractals with simple rules have been able to mimic leaves and mountains very well. This allows people to model such natural phenomena, but also suggests that said phenomena are produced by corresponding simple rules of nature. This tool has been used to create special effects in movies in order to create worlds and devices such as the Death Star from Star Wars. Fractals have also been used to help compress digital photos. Fractal compression is a method for compressing digital images, and it is based on fractals. The method is suited best for textures and natural images, relying on the fact that parts of an image often resemble other parts of the same image. Fractal algorithms convert these repeated parts into formulas, which can then be used to recreate the compressed digital image. So today, we covered the golden ratio and the architecture that used it, the Fibonacci sequence and how to figure it out. We went over symmetry and its relation to pizza. We talked about and explained the three rigid motions. We informed you about fractals and their origins, as well as some of their practical uses and appearances in nature.